Hello everyone, good morning. Today is Tuesday and we're going to be having physics. Okay, we're going to be having a new topic today. Okay, not necessarily a new topic, a continuation of what we were doing in the last class. But before that, I just want to show you something. Okay, so let's look at some fun facts. Okay, so I'm going to show you a picture of a person, and I want you to try to tell me who it is. So can you figure out who this man is? Who is this person? Who is this person? Okay, try guessing, try guessing. Guess, guess, guess. Let's see if you'll be correct. Okay, so the person is Isaac Newton. This is a picture of young Isaac Newton. Yes, I decided to tell you some things about him today since we've been talking about, his work and we've been dealing with his laws of motion. So I said I'll tell you some things about him. So Isaac Newton, yeah, what? Oh, we cannot overstress all the contributions he has made, but let's just discuss some of them. So what's I think off the top of your head you can just think of some of his contributions, but let's just see what has he done. What has he done for us, or what has he done for our world, the world we live in today? So this is a picture of his contribution. I know you're probably thinking, did Isaac Newton create an apple tree, or was he the one who invented apples? Well, no, that's not what this picture is about. This picture is about a story. There's a story that goes around that we know it happened, but we are not sure if that was what led to what he discovered. But that's what is commonly believed anyway. So there's a story that goes around that Isaac Newton was sitting underneath an apple tree one day, and one of the apples actually fell and fell fell on him, and then he just thought to himself, there is a force that is responsible for this apple that falls down, whenever it's ripe. And then he thought about it, and then that was when he came up with the explanation of gravity. So he was the one that brought forth so many theories that have explained the concept of gravity to us today. I know you've heard about gravity, and you've heard this saying that what goes up must come down, right? Yeah, when you jump up, you come down. You don't fly into the sky. Now, although we have some, some, phenomena where some, should I say, animals, for example, birds can escape gravity, right? They fly and all that. So that's a different phenomenon on its own. But Isaac Newton was able to explain gravity, the concept of gravity. We even have what we call Newton's gravitational law and all that. Okay, we're going to get into that, sometime soon, hopefully. So he was the one that explained gravity to us. And then he now thought that, okay, if this gravity could actually affect an apple on a tree, then it means it has its effect on so many other things, even things that are farther away from us, objects that are much, much far and farther away, like the moon, and so many other things that are far away. So he was able to explain this concept of gravity and how it affects different bodies. So you can see, without Newton's explanation, you will probably still not understand the concept of jumping up and coming back down, or why an apple falls down from a tree, or why two bodies are pulled together by gravitational force, and all of that. So we should be thanking Newton for that, for giving us this law of gravitation and the concept of gravity, explaining it to us. So, but he did so many other things. Yeah, he did so many other things. So, what are those things? Now, I don't know if you've heard about the binomial theorem in mathematics. Yes, the generalized binomial theorem that helps you to find the expansion of an exponent. Yes, it was Newton that gave us the generalized binomial theorem. Isn't that awesome? It was Newton that gave us this generalized binomial theorem. Also, I don't know if you've heard of calculus. It was originally called frictions, but now it's known as calculus. He wanted to explain gravity. He had to explain gravity and motion. He did a lot on motion. We've already seen some of that. And then he needed to explain a form of mathematics that would explain gravity and motion. And then the already existing forms like algebra and geometry couldn't explain his gravity and his motion. So he developed a form of mathematics that has a constantly changing states or variable states. You understand? And that's what gave that name frictions. But now we call it calculus anyway. We call that calculus where you have, that calculus is a wide field where you have differentiation, integration. The variable nature of matter anyway is what he used calculus to explain. And that was what he now used to explain his theories on gravity and motion. So anytime you hear calculus, Isaac Newton started it. Some of us that don't like calculus, well, you can't find Newton to beat him up or, or do anything to him. But for all of us that, really want to know about calculus and, like it and love it, we should be thanking Isaac Newton for it. One more thing that he did. This is just, I just picked some of the things he contributed, but there's still a lot more you can find out on your own. So he also had some contributions to optics. Yeah, yes, he did. Apart from the Snell's law of refraction, Isaac Newton also worked on that, law of refraction. But let's just see, how did he do, what exactly did he do? Now we all know that white light can be broken into a spectrum. Yeah, where you have so many other colors, red, orange, and the rest. Now, Isaac Newton demonstrated that with a second prism, you can actually combine these colors back into white lights. Amazing, right? Amazing. Yes, it's amazing. It's amazing. So that was his contribution to optics. That's a part of his contribution to optics. So Isaac Newton did so many things. And honestly, I say, for me, he's one of the fathers of physics because his contributions to physics are enormous. They're enormous. So that's that for fun facts for today. Let's go into our topic for today. Okay, so today, what am I expecting you to know? Of course, we're still on the laws of motion and their application. So the law we're going to be discussing today is the third law. Okay, so I want you to be able to understand that by the end of today's class. Fully. Now, we're on Newton's laws of motion. Yeah. So let's take a quick recap of what we studied in the last class. Now we talked about laws 1 and 2. Now law 1 talks about the fact that a body will continue to move or will continue to be at rest depending on what position it was in, except an external force acts on it. So that's law 1. That's law 1. And that law is often called the law of inertia. Then we talked about law 2, which states that the force applied to an object is proportional to the rate of change of its momentum. We said momentum is the product of mass and velocity. We also mentioned impulse, which is the instantaneous response of the body, you understand, to a force that acts on it. So we talked about a lot in the last class, and I just hope you still remember the laws and its applications and how to use them in calculations. If you don't, you can always rewatch, the video of the last class. So, but let's move into what we have to do today. Okay, so law 3 now. This law was a very funny one when I was in school. Okay, but I don't think I should tell you the example that I was taught because it's not a nice one. But I'll just tell you as a joke anyway. So it's called the law of action and reaction. Okay, so to every action there is an equal and opposite reaction. It's a very short law and it's realistic and it's practical. So every action there is an equal and opposite reaction. Now, it's almost like the law of karma, but law of karma is something else that says when you do something to somebody, you expect it to be done back to you and all that. But that's something else. Now, but there was a funny example that one of my teachers told me in school, very hilarious. And then he was like, if you have an argument with somebody and the person slaps you, you end up slapping the person back. But then we're not supposed to. We're supposed to turn the other cheek, right? And not react, in a negative way. You should always try to react positively to negative actions around you. Okay, but it was funny then. We're still kids and all. But just note that the law of action and reaction simply states that when there is an action, there should be an equal and opposite reaction. Now, as human beings, it's left to you to try to make your reaction a positive one. Okay, but let's talk about it in physics now. So now let me just show you one application of law 3, which is for rockets now. We'll talk about more on the applications later, but I just want to show you this. Now, have you ever seen a rocket before? When it's launched into space or into the air, you see um, burning gas coming out from the ends, right? Now, that action of that gas coming out from the ends is what creates a reaction which propels that rocket into the sky. Think about it. You can see gas coming, burning out from its ends. Okay, now in the same vein, the rocket is propelled into the atmosphere. This is a very common example of Newton's third law of action and reaction. Okay, we'll talk about more of this after we're done with the law. So let's talk about the principle of conservation of momentum. Now, this principle was interpreted from Newton's third law, and it simply states that when two bodies are traveling in a straight line and then these bodies collide, the total momentum, we already know what momentum is, right? Product of mass of a body and the velocity of a body, okay? The total momentum before these bodies collide is the same as the total momentum after these bodies collide, provided that no external force, that's the clause, provided that no external force acts on the two bodies. They're just colliding, there's no external force acting on them. Okay, so what does this mean? Now, the momentum of one body may increase and that of the other body may reduce, but altogether, the total momentum before the collision must be equal to the total momentum after the collision. Okay, so that's the principle of conservation of momentum. Okay, that's the principle. Now, look at this car. It's actually practically the same car, but I'm just giving an example. Now, what if these two cars hit each other? What we are simply saying in essence is that if these two cars hit each other, the momentum as of before the collision, when they were separate, is going to remain the same as the momentum after they collide. Okay, so just think about that and try to understand it. But you don't need to practicalize it. Please don't try to hit two cars together. You don't need to practicalize that. Okay, now let's now talk about the types of collision. There are two types of collision. We have the inelastic collision and the elastic collision. Let's start with the inelastic collision. From the word inelastic, inelastic. When something is elastic in English language, we say it can be pulled apart, or it has that tendency to expand, right? In a way, that's what we say in English language. But in physics now, when you talk about inelastic collision, you're talking about a type of collision where the two bodies, after the collide, they continue moving together. They stick together and they move together. Okay, that's inelastic collision. And they move together with a common velocity. In this type of collision, not only is momentum conserved, kinetic energy is also conserved. It's not just momentum that's conserved here, kinetic energy is also conserved in this type of collision. So we call this inelastic collision. Now let me show you just a picture of two bodies. Now you can see the body in yellow and the body in green. So these two bodies are moving together, they're moving on their own separately with their individual velocities, u1 and u2, and then they now hit each other, they collide with each other, and they now stick together and move together with a common velocity v. Now, how do we say the principle of momentum, conservation of momentum is applied here? It simply means that based on our principle, m1u1, which is the momentum of body 1 before collision, plus m2u2, which is the momentum of body 2 before collision, must be equal to m1 plus m2 into v. Since the two bodies now are sticking together and they're moving with the same velocity, the momentum after collision is m1 plus m2 bracket v. So what we are simply saying is that the collision, that the momentum before collision, the total momentum before collision is equal to the momentum after collision. So m1u1 plus m2u2 equals m1 plus m2 bracket v. That is inelastic collision, for inelastic collision. Let's take a look at something, an example that is similar to that. So a body A of mass 6 kg, moving with a velocity of 10 meters per second, collides with another body B of mass 4 kg, moving in the opposite. Take note of the word opposite direction with a velocity of 2 meters per second. Calculate the common velocity in the direction of body A after collision. Now, first of all, when you see a question like this, it's quite long anyway, but not too long. The first thing you need to do is break it down and write out each parameter that you have. So let's start with the mass. Mass of body A. Let's call body A 1 and let's call body B 2. So mass 1, M1 is 6 kg. U1, velocity of body 1 initially is 10 meters per second. M2, mass of body 2 is 4 kg. Just follow me, 4 kg here. And initial velocity of body 2 is 2 meters per second. Now, we have every other thing. We have to find the common velocity. Okay? Now, our formula remains M1U1 plus M2U2 equals M1 plus M2 into V. That's our formula. It remains that. Now, what we need to do now is substitute every single value that we've written out into that formula. So we can start with M1U1, that's 6 times 10, plus, now please take note of this opposite. It said moving in the body B is moving in the opposite direction. Opposite direction. And since we are to find the common velocity in the direction of body A, we're going to assume the body B as the negative direction. Follow me. So since it's moving in the opposite direction of body A, we're going to use assume that it's moving in the negative direction. Okay, so that's why you can see a minus sign here. Okay, so the momentum of this body is assumed to be negative since it's moving in the opposite direction. So minus 4 times 2 equals 6 plus 4 times the common velocity V here. So if we simplify that, 6 times 10 gives us 60, 4 times 2 gives us 8, so 60 minus 8 equals 10V. Okay, it's not difficult, it's very easy. You just need to break it down step by step, know what formula to use, okay, and then you can move on. Of course, when you say calculate the common velocity, you know that the bodies have stuck together, so you know that that is an inelastic collision. It might not be spelled out that it's an inelastic collision, but there are some key words you should look at for. If you see common velocity, they move with a common velocity after collision, you know that that is inelastic collision. Or if you see words like the two bodies stick together, you know that that is an inelastic collision. So from here we have 52 minus 52 equals to 10V, and then V is 52 over 10, and that gives us 5.2 meters per second. So that simply means that after these two bodies collide, they move together with a velocity of 5.2 meters per second. So that's that for inelastic collision. Take note of those keywords and use them when you're trying to identify the type of collision. Okay, so types of collision again, we're going to elastic collision now. We've explained the meaning of elastic. So in this case now, when we say elastic, it simply means that there is a rebound. The two bodies do not stick together. Instead, after collision, the two bodies rebound. They are not stuck together. They still keep moving in their different, they keep moving in their separate ways. They do not come together or stick together. So in essence, the total kinetic energy of these bodies is not conserved. Momentum is conserved, yes, but the kinetic energy is not conserved. The bodies rebound after collision. Now, look at the diagram here. So we have M1 moving with a velocity U1. We have mass 2 moving with a velocity U2. And then after collision, they each have their own velocities now, V1 and V2. Okay, so when we're to derive that formula here for the elastic collision, we would say, based on the conservation of momentum, that principle, momentum before collision should be the same as the total momentum after collision. So M1U1 plus M2U2 should be equal to M1V1 plus M2V2. So that's our formula for elastic collision. So you should try to understand how these formulas are derived. You don't need to just, you need to put them in your head, but don't just put them in your head without understanding why it is what it is. Okay, it's an elastic collision, so the bodies move with their different velocities after collision. Okay, so try to understand that. Now, let's take an example. And let's see how we can work it out. So a body A of mass 10 kg, moving with a velocity of 8 meters per second, collides with another body B of mass 6 kg, moving with a velocity of 3 meters per second. Calculate the new velocity of body B if the velocity of body A after collision is 6 meters per second. Okay, so let's assume that body A is mass 1 and body B is mass 2. So M1 is 10 kg. We have 10 kg here for mass 1. Then we have U1 as 8 meters per second here. Then we have M2 as 6 kg here, mass 2 as 6 kg. Okay, then we have U2 as 3 meters per second. Then we were told that the velocity of the first body after collision is 6 meters per second, and we are to find V2, the velocity of body B. We are to find V2. So remember that we are using, don't mix up the formulas for elastic and inelastic collision. So always try to understand the difference between the two. So in this collision now, it's elastic. They are not stuck together. They are not moving with a common velocity. So those keywords are absent, and it says that we should find the velocity of body B, especially after collision. So this is elastic. So we use our formula there, and we can substitute 10 times 8, okay, plus 6 times 3 equals 10 times 6 now, plus 6 times the velocity 2, the second one, velocity of the second body after collision. So let's move on. So we have 80 plus 18 equals 60 plus 6v2. Now that gives us 98 minus 60 now equals to 6v2. So 38 equals to 6v2, and v2 is 38 over 6. So that gives us 6.3 meters per second. Okay, so the velocity of the second body after collision, okay, after collision is 6.3 meters per second. Okay, so that is that for for elastic collision. So try to remember the difference between inelastic and elastic collision. Try to be able to define, define them accurately, know what is conserved, what is not conserved, and know the concept, the concept behind each one of them. Okay, so let's move on to applications now. Okay, applications of Newton's, third law. We talked about propulsion of the rocket. We can also say propulsion of the jets. That's another one similar to the rocket. Now let's talk about the recoil of a gun. The recoil of a gun. Now you've seen a gun before, obviously not up close, not up close. Some of us might, but I doubt that. So, but if you watch some movies, you might have seen a gun somewhere. So this is a picture of a gun and a bullet. Okay, so now let's talk about the recoil of the gun. Now let's talk about how the gun actually works. Now you have the part where you actually press. Okay, you press that part. You can see the finger on the trigger. It's called the trigger. So when the finger is on the trigger and the finger, you apply pressure to the trigger. Now the bullet shoots out of the gun, right? The bullet shoots out of the gun with a force, with a very high force, which now enables it to penetrate into the enemy's, body. Now, as the bullet is propelled out of the gun also experiences what we call a recoil. That recoil is the backward force of the gun, and that is what the person holding the gun feels. If you're just going to be practicing, maybe you go to a shooting range and you're trying to become a police officer and you're practicing, shooting a gun, you would feel that force. And if you're not so stable, it might even, it might even push you to the ground. But I trust you'll be very good with, if you're trying to be a police officer, you'll be good with, what you're trying to do. I trust that that would be the case. So, but you would feel a recoil of the gun, the force, the backward force that propels the gun backward is what we call the recoil of the gun. Now, that is the reaction which is equal to the action of the bullets. Okay, so the bullet is propelled forward and there's an equal and opposite reaction of the gun backward. Isn't that amazing? It's amazing. So let's now talk about how this, based on the principle of conservation of momentum, we can determine the velocity, the recoil velocity of the gun. Okay, let's look at that. So let's say that M, small letter m, is the mass of the bullet, and let's say that capital letter M is the mass of the gun, and let's say that V, small letter v, is the propulsive velocity of the bullet. That's the velocity with which the bullet moves out of the gun and penetrates the enemy's body. So V is the propulsive velocity of the bullet, small letter v, and capital letter V is the recoil velocity of the gun. Now, based on the principle of conservation of momentum, we can say that mv, the small letter m times small letter v, is equal to capital letter M times capital letter V. Okay? Remember that momentum is conserved. Okay, so mv equals mv, capital MV. So if you want to find recoil velocity of the gun in a scenario where you're asked to find, you could be asked to find any other thing, maybe the mass of the bullet, the opposite velocity of the bullet, or the mass of the gun. You can then decide to manipulate the formula as you like. Okay, but let's just see for recoil velocity of the gun. So that would be capital V equals mv, small mv, over capital M. Okay, so that recoil of a gun is a very interesting application of Newton's third law. Okay, so that's that for the recoil of a gun. So let's quickly summarize. We talked about the third law, and we've said to every action there is an equal and opposite reaction. I love Newton's third law, it's so interesting. So we also talked about, we talked about the principle of conservation of momentum. We said the momentum before collision of two bodies is the same as the momentum after the collision of those two bodies. We talked about the types of collision. We said we have the inelastic collision and the elastic collision. We defined each one, and we also gave the formulas for each one and looked at some examples for each of them. Then we talked about the applications of the third law. We know the application as we talked about the jets, propulsion of the jets into the atmosphere, into the sky. We talked about rockets. Of course, we talked about a rocket. You saw a picture. And then we talked about the recoil of the gun. How that when the bullet moves out of the gun also has a recoil, okay, a recoil force that moves the gun backwards, okay? So that's a summary of everything that we discussed. So try to always understand the concepts. Don't just try to, cram the definition, cram the formula. No, you can try your best to always see how was this formula obtained, how is this concept the way it is. It's always important that you always search for facts, always be inquisitive, try to figure out what you're doing, analyze it, synthesize it, try to apply it if you can. Okay, so that's that for our class for today. Let's just look at something I want you to do for me, and give me feedback in the comment section if you are able to get the correct answer. Of course, this is a theoretical one, so you should be able to state the law of conservation of momentum and explain it. So you can do that and just put it in your own words if you can, and leave it in the comment section. Then I also want you to be able to differentiate. Of course, from what we've explained, you should be able to say the difference between elastic collision and inelastic collision, and also give the formulas for each one. So you can do that also in the comment section if you want to. And of course, you can try to visit quizzes.com and play some games on motion, Newton's laws of motion, equations of motion, collision, and so many other things that we have discussed. So remember to like the video, remember to share to your friends to help them with this topic. Remember to also subscribe for weekly updates, and I'll be waiting for your comments in the comments section. So I hope you had fun. I had a lot of fun with this topic. I actually love this topic, and I hope you actually love it too. So I'll see you guys next week for another physics class, a different topic. Take care of yourselves and have a lovely day. Bye.